So hello everyone, and today we'll be seeing one of the problem from Leetcode. It says search in rotated sorted array. The problem is very simple and straightforward. We are given an integer array nums sorted in ascending order with distinct values. Prior to being prior to being passed to your function, nums is possibly left rotated at an unknown index such that the resulting array is nums of k, k plus 1, n minus 1 and 0 to k minus 1. So the smallest element is residing somewhere in between, which we don't know. Might be left rotated by 3 index become, so this array left rotated by 3 becomes like this. You see, it is a kind of sorted but not entirely sorted, and yeah, likewise we have to go forward. Given an array nums after the possible rotation and an integer target, return index of target if it is in nums or -1 if it is not in nums. Again, we need to find an algorithm which would run in log n time complexity, else you can just use a linear search and just do it. But yeah, log n time complexity, we need to solve it one, and array is something like this. If find, return the value. If not, if find, return the index 0, 1, 2, 3, 4, yeah, return the index, else return -1. Now how are we going to solve this one? You see, one major clue we have given it is a rotated sorted array. So we know here or there somewhere we are required to solve this via binary search. But how do we apply binary search if we don't know left and right? Because binary search applies on the principle that hey, I know the farthest left function, left value, the farthest right value, and then I can predict whether it is on left or right. But here neither we know the left or right, the min, the max, we don't know that. One thing we know for sure that hey, it is rotated sorted, and there is only, and within this we can just find a random min, and we can understand that hey, within this mid, left and right, I can at least understand whether left to mid is sorted or mid to right is sorted, and accordingly we can search that way. So if left to mid is sorted, I can consider this as a sorted thing. Why consider? It is a sorted thing, and search my target within this if it falls within the range. If not, I'll search my target here. Plain, easy, simple. So without any further delay, let's see how we can do this one. So I'll just return search nums with left and right nums.length -1 along with the target we need to find. Obviously an overloaded function search, which would take an array A, left L, right R. Again, this naming convention is totally short-handed because yeah, ideally you should use a proper naming convention over here. Now if I'm seeing that hey, your left is greater than R, I am pretty much sure that I'll not able to find this one, so return -1. What I'll do here is I'll figure out mid. How can I figure out mid? L plus R minus L divided by 2. So I have got the mid. Let's say we are being too lucky. And we find out that hey, A of mid itself is X. At that moment we return mid because we need to return the index, right? Now let's say if we are not being that lucky, then how we need to find? Again, we can check whether we have left to mid sorted or not. So we need to have a mechanism where we can say left to mid is sorted. How we can do that? So if I can say left is less than or equal to A of mid, that means it is sorted. Yes, I can say that. Else, if it is not the case, I'll say that mid to right is sorted. Well, so far so good. Now what I'm interested more is to check whether if our x, our target, whether this lies within the range of L to mid, A of mid, sorry, x is less than or equal to A of mid. So if this happens, we are again lucky that it is sorted again, and we find out that hey, this is within the range. So I'll just go ahead and return search of A left to mid minus 1. Why mid minus 1? Because I have already checked mid. I know mid is not equal, so that is why mid minus 1, and target x. If that is not the case, unfortunately, then again what we are trying to do over here is not to search on left and mid minus 1, but mid plus 1 and right. In that way we know that hey, even though it is sorted, but it is not falling within the range, so let's not consider this but that. Now what if this is not true, but A of mid minus 1, sorry, A of mid is less than or equal to x, and x is less than or equal to A of r, because like L to mid, it is mid to r. Same, return search of A mid plus 1 r and x. If that is not a case, then it is not falling within the right half, so we should check for the left half. And within the every point we are just doing left and right for binary search. So we checked right half was not true, so what we'll do, we'll check left half, mid minus 1 with x. Ultimately I'll return minus 1. No need to return, by the way, because every statement returns here. So yeah, let me try to compile this one. It passes for sample test case. Let me try to submit this. And yes, it got submitted for all 196 test cases. So this was a very recursive way to approach this problem, because it is quite simpler, it is cleaner approach over like this, and you can find out iterative way as well, and that is also an awesome thing. If you know about that, or if you came up with a solution of iterative approach, do share, do contribute to the repo I have mentioned below, and I'll see you in the next one.